Okay, another quick example on how to solve system of linear equations using matrices. I'm gonna go fast this time, so you'll see it doesn't take 17 minutes like the last video to do it. So we can, just to show you, we can do this a little faster. Okay, so remember, first step, and I'm gonna use different pages and try to use different pages to help us go a little faster. First, we write our matrix A, right? Matrix A will be, 9, -4, 5, and 5. Then multiplied by our, variable matrix, which is matrix X. Sorry. Okay. And then our answer matrix 6 and 25. This is our matrix B. Remember, our goal is to take our matrix A times matrix X. We need to solve for matrix X, right? So we need to find the inverse matrix A, right, with a little -1, that will make those two cancel. And then we have to multiply on both sides, because the golden rule of algebra states that if you multiply something onto one side, you have to do it onto the other side. So this is what we're going to be doing right now, okay? So we are going to be doing this. I'm just going to erase this. We're going to start by finding the inverse matrix. Remember, by finding the inverse matrix, the first step is to find the determinant. Determinant of 9, -4, 5, and 5. We are doing 9 times 5 is 45, minus -4 times 5 is 20. So we're going to do plus 20. Get a big number again, but doesn't matter. We get 65 here. Good. So this is our determinant. So we need first, and remember the second step, we need to take this, the matrix A, and do a little bit of switching around. So we switch, remember we switched the 9 and the 5. So you put a 5 here, the 9 here, and you change the sign of, so this one becomes positive and this one becomes negative. And then now we're going to multiply by 1 over 65. Remember what I told you, keep the denominator, because you see at the end when you're solving for x and y, it's so much easier because you're adding fractions with the same denominator. Because if you start simplifying, then you're going to get different denominator, then it becomes a little bit more tricky. And then my inverse matrix goes this way. 5 times 1 over 65 is 5 over 65. Then we get 4 over 65. Then we get -5 over 65. Remember, you do a matrix, you do a scalar multiplication, and then 9 over 65. Now we have our inverse matrix. You don't need to multiply it by your matrix A. You know they cancel out. I mean, you have to trust yourself. I mean, unless you really want to do it during a test to make sure you did it correctly, but don't waste your time. If you take your time and you do your steps well and your arithmetic good, you shouldn't have any problems with that. Okay, so now what we're going to do, and last step, you see how fast it goes? The last step is to multiply my inverse matrix by my matrix B to solve for x and y. -5 over 65, 4 over 65, and 9 over 65. Multiplied by 6 and 25. You see this matrix here, we're multiplying here. Good? So we get, I'm going to try to find a way to just move. Okay. I'm getting some space here. So we're going to start, I'm going to color code. Remember, you do 5 times 6 over 65. So it's 30 over 65 plus 4 times 25. It will be 100 over 65. So we get 130 over 65. And we get an answer of 2. 130 divided by 65 is 2. So the first answer is, and I promise, guys, okay, I'm going to give you something right now. Any numbers we'll have on the test will be a whole number. The answers will be whole numbers. So if it doesn't give you a whole number there, it means you made a mistake along the way. So that's going to be your cue. Okay, so we found the value of x. X is positive 2. And then we're going to do the same thing. What is -5 times 6 is -30 over 65 plus what is 9 times 25? we get 225 here, 225 over 65, right? It's positive, so minus 30, we get 195 over 65, which gives me 3. We just found the solution of the system of this equation using inverse matrices. Okay, again, you may tell me substitution or elimination is much faster, but you'll be surprised to see how many students prefer doing this over time because it's so much faster. It becomes so much faster. Okay, and quickly, next, what is the first thing we have to do? Number one, you write your equation into matrix, right? Into a matrix. A matrix. In the form of matrix A times matrix X equals matrix B. Step number 2, find the determinant. The determinant. Okay? The determinant of matrix A. Of determinant of A, right, of matrix A. Then find the inverse using the determinant. I should even say here, just to make a nice flow here, using the determinant A. Remember, determinant is like when there's two lines, you can still use that same symbol to represent a matrix, a determinant of a matrix. Whoops, using a determinant matrix A, find the inverse of matrix A. Remember that this is inverse. Find the inverse. And then once you have the inverse, finally solve for matrix XY. Could be AB, any letter, right? By multiplying matrix. Remember, you put the inverse matrix first by matrix B. There you go. This is the way to solve a system of equation using matrices. Now, next class, we're going to do the exact same process, but we're going to do that on a calculator for a 3 by 3 matrix.